Hi friends, in this video I will discuss the introduction and history of nanotechnology. And nanotechnology has gained a lot of interest in last few decades due to their application in diverse fields of technology and also in our daily life. So how small is nano? That nano, it originates from the Greek word for dwarf, and it is a billionth, 10 to the power 9 minus 9 of a unit, and it deals with the synthesis, characterization, and utilization of nanostructure materials. And these materials are characterized by at least one dimension should be in nanometer range. And nanoscience is the study of the materials at atomic or molecular state and how the atoms or molecules are manipulated and the study of their properties, because their properties it changes significantly at lower scale. And nanotechnology is it is design, characterization, and application of these structures or the properties of the nanomaterials by controlling the shape and size to make the devices. So bulk materials, whatever we see from our eyes in our daily life, that is, these are bulk materials, and they possess some continuous physical properties. Means if you have a piece of gold, it should have similar properties at in 1 millimeter. If we go 10 centimeter or at other end, then the properties should be same. So these are the properties are continuous. Also, the properties are found similar in case of the micro-sized particles like powder of a material or sand. So properties are not very different from the bulk material. But there is a big difference when we go to particle sizes to nanometer range. And at these dimensions, quantum mechanics principle they dominate, and that's why their properties changes drastically. Suppose we take the example of gold or silver, and it have different properties at nanoscale as compared to their bulk material. Nanomaterials are those materials which have at least one dimension should be less than 100 nanometers, and a sheet of paper is around 100,000 nanometer thick or 100 micrometer thick, and similarly human hair is around 80,000 to 100,000 nanometers thick. So we can compare some of the dimension in this image, and we can see the sizes are decreasing to left, and the particles of sand are around 1 millimeter. The pollen are 100 micrometer. So bacteria, red blood cells in few micrometers, and the viruses are around 100 nanometers, and protein DNA they are less than 10 nanometers. And this is carbon 60 or fullerene, which have dimension around 1 nanometer, and the atom has dimensions around 0.1 nanometer. In this image we can see that nano is a very small unit, as if we compare the radius of earth, which is around 12,756 kilometer, to a soccer ball or football which have diameter 22 centimeter. So it is a ratio of 10 to the power 8 times. Similarly, if we compare a ball to a atom or nanomaterial, then it is again 10 to the power 8 times. So atom have dimension 0.1 nanometer. So 10 atoms will make a nanometer. So nano dimension is very small dimension. And 1 meter we know that it is 10 to the power 0 meter, and 1 nanometer is 10 to the power minus 9 meter. So 1 nanometer is equivalent to the 10 atoms of helium or 5 atoms of silicon. They are aligned in a line, then it will make 1 nanometer. And the sizes of electrons are around 2 into 10 to the power minus 9 nanometer proton and neutron have 10 to the power minus 6 nanometer. So we briefly discuss the history, and the nanotechnology is not a new field, and it has been used by people from thousands of years. And Egyptians were using the black pigment as ink, using the nanoparticles of black pigment as ink, and also the nanoparticles of lead sulfides were used by the Romans to dye their hairs. Also, the nanoparticles of gold and silver, they were used since 10th century in stained glasses and to color the ceramics. And one example of this is the Lycurgoscope, which is an example from Roman era, in that some silver or gold nanoparticles were mixed in the glass matrix to make some colors or to have some good optical properties. And Lycurgoscope is like this. It is made from the dichroic glass, and which shows different colors when light falls on it from the behind and from the front. And these cups are still in the museum, London Museum. And here we can see the color is red if the light is coming from behind, and this color is green when light is coming from the front. Now we discuss the modern nanotechnology, and the first concept was given by Richard Feynman. He was a famous professor of physics, and in 1959 he gave a statement that there is plenty of room at the bottom. Means he was talking about that when we go at atomic scale at nano scale, so there are drastic change in the properties. And after the invention of the scanning tunneling microscopy in 1981, and after the discovery of fullerene C60 in 1985, there are a lot of work have been done in field of nanotechnology. And the term nanotechnology was used by uh, Japanese scientist Norio Taniguchi in 1974. And in ancient India, also the Damascus steel, means steel filled with carbon nanotubes and nanowires. It was used by South Indians in Tamil Nadu and Kerala to make the weapons and swords around 17th century, and they were very, the strength was very high, and also there was no rust in it. So, and European also buy that steel from India. And when the scientists go at the lower scale or smaller scale, then they need some new equipments to characterize these particles. And in 1981, a device, scanning tunneling microscope STM, was invented, and it allowed to scientists to see the nano world or the nanomaterials. And using an STM, one can see the individual atoms. And in 1989, an STM was used to move 35 xenon atoms on a tiny piece of nickel, and this was done by the scientists of, of IBM company, that is International Business Machines Corporation. And there are nanoparticles in nature, and we have some examples like lizards and some insects have nanostructure on their feet so that they can walk on the wall. Also, spiders, they make the fibers and which have very high strength. They can, it is nanofiber. And also butterfly wings, they contain some reflective nanocrystals, because these wings are just black and white, no colors are there, but there are some nanostructures, and when light falls on these structures, they are due to interference, we can see different colors. Also, in case of the plants, the chloroplast makes this changes the sun energy into glucose in case of the plants. So scientists try to copy these natural nanoparticles and their properties to make the new materials that are useful and applicable to the devices. Natural nanoparticles are already, we can have some nanoparticles from the big scale to lower scale. Suppose wind erosion or due to weather or wind or volcanic activities or some dust particles are there, they can also make some natural nanoparticles. And also uh, from lower scale means when thermal energy or solar energy or some biomass combustion, we can get some kind of smoke or some particles in air, and these all natural nanoparticles are always in our atmosphere or in uh, environment. Also we can see that there are different PM labels which can tell about the dimension of the particle. Suppose PM10 means the particle is of 10 micrometer, and we can see that HIV have sizes around zero point 0.1 micrometer, and the coronavirus recently before few years we have seen that there was this SARS-CoV-2 virus or coronavirus. It have also the sizes around few hundred nanometers, and the properties of nanomaterials are very different as compared to their bulk counterpart, and nanomaterials are more reactive as compared to bulk material. Their melting point decreases as we go at nanoscale. They can have different colors. Different colors mean their optical properties are different and depends on the size of nanoparticle. And there are changes in electric and magnetic properties also, and their mechanical and other properties also varies in case of the nanomaterials. And why the properties are changing drastically at nanoscale? So there are two reasons. First one is the high surface to volume ratio, or it results in the large fraction of surface atoms. And second one is the quantum size effect, which are dominant at nanoscale. So it is also known as the quantum confinement. So we will discuss these in next lectures on size effect and basic quantum mechanics like particle in a box. So we will discuss in future lectures. Property of nanoparticles. Suppose we talk about the optical properties or appearance. So if we take an example of gold material, gold is there, a bulk piece of gold is there, and gold is yellow in color. Usually it is yellow in color, but nanoparticles of gold can be red or blue depending on the size of the nanoparticle. So different size nanoparticle gives different colored solutions. These are the solution made by Professor Michael Corte, and smaller nanoparticles appear red in solution, and when the sizes are increasing, it goes towards blue color, and this is due to the change in the energy band gap, because usually gold is a metal, it is very good conductor, but the nanoparticles of gold, they can be insulator also, so there may be some kind of band gap. So the optical property changes with the size in the nanoparticles. There are several applications of nanotechnology. Some we can list here. Suppose it is used in computer or information technology, communication. So large memories use the small nano or nanoparticles. Then we have a very good memory. It is used in nano electronics, biomolecules as transistors. So people are also working in this field. Medical and healthcare, we have nano drugs, anti-cancer drugs, dental paste, biosensors. In energy, we have, it is used in solar cells. Very thin layers of solar cells are there. Nano materials are also used in fuel cells. In batteries, nanocomposites are used as electrolytes. Uh, And in automobile industries, it can be used as lubricants, phosphorus, glass coatings, resins. In different industries like ceramic, auto, or mechanical industry, sensors, these all are the areas where the nanomaterials are used. In defense, some specific materials use the nanomaterials. They are used in sensors and also in intelligent clothing, means the color of the cloth can change depending on the environment. In cosmetics, it is used in as skin creams, anti-aging creams, and in talcum powders. So nanoparticles are there. Food and agriculture industry, and for water purification also, water treatments. In environmental, nanocatalysts, textile industry to make the wrinkle-free clothes or some special kind of clothes. In sports, to make the sunglasses and also rackets of tennis and hockey sticks, golf balls. So there also the nanomaterials are used. In aerospace industry, uh, it is used for lightweight materials and for also making uh, good strength materials, or uh, for communication purposes also in aerospace industry, nanomaterials are used. And in oil and gas industry, most of the oil wells are they are uh, for the extraction, the nanotechnology is used. So this is the world's smallest motor made by 16 atoms. These are the atomic arrangement, and these are the AFM image, atomic force microscopy image, real image, and it was made by the scientists from the Switzerland in 2020. Now we discuss the Moore's law or Moore's law, which tells that in every 18 months the number of component on an integrated circuit, it gets double. And this tells about the size of the transistor. Initially it was in centimeter, then it goes to micrometer range, and now it is in few nanometers. And with every year the sizes are going down and down, but now it is getting saturated. And then this is the how chips are there, and there are a lot of millions of transistors on a chip. And Moore suggested in 2007 that size of the transistor cannot go beyond the atomic size 0.1 nanometer. So we have not reached at this scale till now. Now we will talk about some storage devices. So there are magnetic storage, and in 1990s there were these audio tapes, video tapes, and floppy disk were also there, and the hard disk type, they are still in use. And in optical storage were used in CD and DVDs, and it needs some kind of light to read these devices. And also there are solid state storage devices like USB or flash drive, or these memory cards, and also the solid state drives. And the unit in memories are 1 byte equal to 8 bit, 1 kilobyte is 1024 bytes, 1 megabyte is 1024 into 1024, and similarly gigabytes and terabytes are also there. So now we will just briefly discuss what are the differences in hard disk drive and solid state drive. So solid state drives are the semiconductor memories, whereas these were the magnetic memories, hard disk drive. SSD are much faster, and these are slower as compared to SSD. But SSD have shorter life, it have longer life. SSD are expensive, these are cheaper. And SSD are best used for the operating system, whereas these hard disk drive or magnetic memories are used for storing extra data. And these are non-mechanical devices. These are mechanical, it has some moving parts, that's why it makes some kind of noise when your hard disk is working. And the trends of nanotechnology in 2023 are based on these materials: carbon nanomaterials, semiconductor nano devices, green nanotechnology, nanocomposites, nanosensors, nanofilms, nano and nanocapsulations, energy nanomaterials, and in also used in computational nano technology and also in nanorobotics. So these are the applications in present years. So in this video, we have discussed the introduction and history of nanomaterials, and in next video we will discuss the crystal structure and symmetry operations of crystals. So if you have any queries or suggestions, please write in the comment box. Thanks for watching, and if you are new to this channel, then please subscribe. Thank you very much.